Assalamu alaikum. Bismillahirrahmanirrahim. Welcome to our Juniper Service Provider Routing and Switching Specialist course. Today we discuss RSVP, that is RSVP Constant Shortest Path First, and admin groups, CSPF and admin groups. So let's start. And this is our topology, and this is the slide. There is three sections in this RSVP constant shortest path first and admin groups. Number one section is CSPP algorithm. Number two, CSPP algorithm try-breakers. And last one is configuring admin groups on LSP. Okay, the CSPP algorithm, constant shortest path first algorithm. This is some key terminology when we study MPLS. We already know the key terminology details. Start constant shortest path first. That means CSPF. CSPF ran an advanced version of shortest path first using the TED, Traffic Engineering Database. When we enable RSVP, there is backend Traffic Engineering Database is enabled. Okay. We configured LSP in previous classes, were not considering the CSPF. That is, when we configure LSP, just say show you the last LSP configuration sample. We're not considering CSPF. Right. Edit protocol, MPLS. Under MPLS, we're creating LSP. Okay, but there is no CSPF. There is no CSPF. So today we discuss what is the CSPF and how to implement this. Okay, constant shortest path first. So let's start. The algorithm. How does CSPF work? Compute LSP one at a time. Prone links that are half duplex, prone links that do not have enough bandwidth, prone links that are not tagged with mandatory admin groups, prone links tagged with admin groups that should be avoided. There's multiple options when we configure CSP. We have to consider this. Okay. Except also the remaining partial topology, are there any strict or loose jobs? Okay, when we manipulate path, we are using straight hops, loose hops. You already know what is straight, what is loose hops. Okay, if yes, SPF runs from the ingress router to hop A, then from hop A to B, and so on. When you configure straight or loose hops, links are removed during is SPF run to avoid loops. If no, SPF runs from ingress directly to egress. Okay, so during is SPF run, if equal cost path exists, pick one path the least hops. If equal cost path still exists, choose a path at random. There are two other options. So when you get multiple paths, but those paths are equal, so in that case, they choose or pick any one, or you take it random one by one. Okay, it's basically depends on backend LSP load balancing mechanism. Okay, reservable and available bandwidth. Reservable and available bandwidth. You already know when you check the RSVP status. See here where reserve 400 bandwidth, 400 bandwidth. So 400 bandwidth. Sure, RSVP interface. See here, we're taking 400 Mbps bandwidth. In the interface, now available bandwidth is 600 Mbps. 400 Mbps bandwidth already reserved. Okay, so here reservable and available bandwidth. So now reservable bandwidth is 600 Mbps, that is available for in our topology. Okay. So before moving on, be clear on the following terms. Reservable bandwidth. What is the reservable bandwidth? The total bandwidth an interface can offer. So in gigabit Ethernet, interface offer the reservable bandwidth is maximum reservable bandwidth is 1000 Mbps. This is the basically available bandwidth. It's basically the available bandwidth. Okay. By default, this is the actual interface bandwidth. Remember that you can oversubscribe or undersubscribe an interface. You can do. Available bandwidth. What is the available bandwidth? The total reservable bandwidth minus the bandwidth of all the LSP on the link. Then you will get available bandwidth. Consider here your reservable bandwidth is this is your total bandwidth 1000 Mbps. This is reservable bandwidth. Reservable bandwidth. You already reserved 400 Mbps, so you have only 600 Mbps bandwidth available. So this is called the available bandwidth for use. CSPAP available bandwidth ratio. 10 Gbps link, 10 Gbps link, 1 Gbps reserved. That means 9 Gbps available bandwidth, 90% available bandwidth ratio. So if you consider 1000 Gbps link, for 40 Gbps reserved, that means 60 Gbps available bandwidth. So this is the reserved and available bandwidth calculation. It's very simple. So now we are in Q&A section. So number one question is, which statement expresses the concept of available bandwidth? Available bandwidth. So available bandwidth is the total bandwidth minus the bandwidth of all the LSP on the link. LSP reserve bandwidth will be minus from the total bandwidth. Okay. Question 2. How does the CSPAP algorithm work when computing LSP one at a time? By starting with high priority LSP, by pruning links that do not have enough bandwidth. This is the scenario. Now we are in section 2, CSPAP algorithm, try-makers. This is some terminology you already know. CSPAP, a closer look at the try-maker part 1. So this is the topology. See here, the link speed is 10 Gbps. This link speed is 100 Gbps. Reserve is 1 GB, available 9 GB. Available ratio is 90%, and the 100 Gbps link reserve bandwidth is 40 GB, available bandwidth is 60 GB, the available ratio is 60%. So we have to know some key terms, that is, one is most field, least field, random path. What is this? So how does CSPAP choose between equal cost path with equal hops? You have one topology that is that have equal cost path with equal hops. So what can do? By default, CSP chooses random path. This is the default nature. This is the default nature. And you can get it from the command run show MPLS LSP name. My LSP name is BMX5. See here, then uh, detail or extensive. Details or extensive. You can see the load balance. The load balance method is random. Okay. So default nature is random. Default nature is random. So you can change this too. Choose the most field, choose the most field, most full path, or you can choose least full path. So what is this? Most full and least full. We'll discuss later what is most full and what is the least full. But fullness is not judged by the available bandwidth. Okay, it is judged by the available bandwidth ratio. Okay, in this example, we're taking 10 Gbps link. There is 90% available. That is less full. Then the 100 Gbps link, 60% available. So if we compare based on ratio, the 10 Gbps link available ratio is 90% and 100 Gbps link available ratio is 60%. So it's basically depends on available bandwidth ratio. Okay. Then the tiebreaker, see this one. So we're just consider this router is the ingress router and this router is the egress router. This is the path. So if you consider the upper path, the bandwidth is 10 Gbps and 100 Gbps. The lower path 100 Gbps, 10 Gbps. That is equal path. Okay, so the 100 Gbps link clearly has more bandwidth to offer, but remember this is tiebreaker is only for path of equal cost. Okay, when would a 10 Gbps and 100 Gbps link be equal? If you manually change the matrix or if you are oversubscribed or undersubscribed your interfaces. So this is your option. You can choose. Okay. So CSP random, least field, and most field. So random is the default behavior. Three ways to influence who is equal cost path CSP selects. Number one is random, the default behavior. This is the default behavior. That choose random. A roughly equal number of LSP will be placed on his path. Second one is least field. Choose the path with the largest available bandwidth ratio. Largest available bandwidth ratio. So, and most field is choose the path with the smallest available bandwidth ratio. Most field. So you can define this. You can define this least field. Least fields means bandwidth ratio is higher, largest available bandwidth ratio. When you choose least field, they are choosing LSP will choose largest available bandwidth ratio. When you choose most field, they are taking smallest available bandwidth ratio. So this is the key difference between among random, least field, and most field. So this is one sample configuration. One sample configuration. They are using random, most field, or least field. There is three different LSP, and they are choosing different load balance method. Different load balance method. Okay. So random is the default. Other is explicitly configured. So if we edit protocol MPLS. Sure. So the LSP is labels is path. Then This see here random select among equal cost paths. So there is two more options. Number one is list field. Select the list field among equal cost path. And another one is most field. Most field. Select the most field among equal cost paths. So you can choose another load balance method. So I'm configuring here another load balance method. The method is most field. See now the LSP status, stencil, and the load balance most field. So there is the changing. There is the changing of default behavior. It is basically depends on your configuration. Okay, that is not automatically happened. You have to configure under LSP. After that, LSP choose whose path they are taking to go egress router. Okay, then the topology for this example, see here, which path will router A choose to get to router B? Router A, this is the router A, and this is the router B. And this is the available bandwidth ratio. This is the available bandwidth ratio. There is three different paths. And available bandwidth ratio is 30 and 35%, that is 65%, 18%, 20%, and 15%. There is 35 and 10, 45, 45 plus 3, 48%. And upper this one, that is 85 and 65%. So which path will router A choose to get to router B? There is three path. Okay, metrics are adjusted so all paths are equal cost. Considering here all paths are equal. Metrics are adjusted under the backend. So available bandwidth ratio on its link is shown. Available bandwidth ratio. This is the available bandwidth ratio. So the default NASR will be random, and based on available bandwidth ratio, you can configure your LSP. Okay. Metrics are adjusted so all parts are equal. Available bandwidth ratio on its link shown. Next topics look at most field and least field. So least field, first one. Choose the path with the largest available bandwidth ratio. Largest available bandwidth. 85% available bandwidth. 65% available bandwidth. There is most available bandwidth available bandwidth available in this path. So look at the top orange path. This is the orange path that is 85% and 65%. More bandwidth available than all other path. More bandwidth available in this path. Okay. So we got a winner. This is the orange path will be the winner when you consider least field. Okay. Most field. Smallest available bandwidth ratio. This is the smallest bandwidth ratio, 30 and 35. That is 60. No, blue one is the smallest available bandwidth ratio. That is 18%, 20%, and 50% available. So, but it has more hops. There is more hops. Two hops, and this is single hops. Available bandwidth ratio is smallest, but hop is higher than others. Okay, so the red bottom path is chosen. It has only 30% and 35% available with single hops. Okay, then we know what is the least field and what is the most field. Okay, so least field is the smallest available bandwidth ratio, and sorry, most field is the smallest available bandwidth ratio, and least field is the highest available bandwidth ratio. So, and if you see the topology, so you have to consider two options. One is a host count, and another one is equal cost. Equal cost. So now we are in question and answer section. When on question number one, when should you use the most field stipend to influence the equal cost path CSP? So to choose the path with the smallest available bandwidth. And number two is to avoid the bean packing problem. Which option can be used to influence an equal cost path? Random, least field, and the most field. And we're in last section. The section is configuring admin groups on LSP. How to configure admin groups on LSP. Administrative groups. You can tag links to be avoided or only be used. Many names for this mechanic like administrative groups, admin groups, affinity groups, affinity bits, link coloring, and so on. So let's see the topology here. There is 10 router is connected with each other. Uh, there is two different link. One is blue link and another one is orange link. Okay. You could tag link to be avoided or to only be used. Many names for this mechanic. Blue links is diagram are high bandwidth, considering high bandwidth links, and red links, that is new links to avoid while you test stability. So this is the consideration. Define admin groups under the protocol MPLS hierarchy. Define admin groups under the MPLS protocol hierarchy. Like set protocol MPLS admin groups. So this is the admin group's name. Admin group's name, a high bandwidth. Admin group's name, brand new. So after the naming, we are choosing the number here. We'll give each group a name and number from 0 to 31. So you can configure total 32 admin groups. Only the number is advertised, not the name. Only number is advertised, not the name. Name is locally significant. Therefore, crucial that you deploy this exact mapping of name to number on all boxes. The given config is added to all 10 routers. That means you have to configure all the routers. You configure only single routers under MPLS, so it will not work. It will not work. Okay. So the configuration protocol MPLS, under protocol MPLS, you have to define the admin groups first, and then configure admin groups in the interfaces. So you can say there is two steps. Number one is you have to define the admin groups and you have to apply these admin groups in the interfaces. So first one, the verification. So see the verification, show MPLS interface. Show, so checking this one, run show MPLS interface. So there is no admin groups here. Okay, there is no admin groups. Okay, so if you configure the admin groups, so you have to set admin group. Your command will be admin groups. When you create the admin group, the command will be groups, admin groups, and set your name like IISNC is high bandwidth, and the number, the group hello. Group value is setting here one, and another admin groups is brand new, and the value is two. Okay, so you are defining the admin groups here, and there is two interface under MPLS protocol. So the interface, set the interface, and admin group. The admin group you can set here, high bandwidth, and another interface is interface one, and this interface considering another admin group is brand new. Okay, so this is your total configuration. First, you have to define the admin groups. Second, apply these admin groups in the interfaces. So comment this one. So this is the step. Configure the admin groups. You have to configure all the router in your topology. OS is under the MPLS backbone. Okay, MPLS interfaces, and you will get the difference. Okay, see here the admin groups assignment. Let's move. Show MPLS Enterprise and admin groups. How are they advertised? So there are 32 admin groups in total. So we can ask why 30? Because OSPF and ISS advertise this on its interface as a single 32-bit value. Each bit represents one group. The bit values go from 31 on the far left to 0 on the far right. In this example, bits 31, 29, 9, and 1 are set. Okay, this is the 32-bit number. That is 1, that is 9, that is 29, and this is the 31 bits. So admin groups, there is some consideration when you configure the LSP. See the LSP configuration, that is level switch path. The LSP name is example 1. You can attach the admin group, include any. This is the one parameter, and another way is include all. So what is the meaning of include any? What is the meaning of include all? So include any means a link is valid if it is tagged with at least one of these admin groups. Okay, so you are just configuring one LSP. They are traveling one ingress router to another egress router. In this transit path, you have to match any one admin groups. If match, this LSP will work, otherwise not work. So include all. A link is valid if it contains all of these admin groups. All of these admin groups will be available in the transit path. Otherwise, your LSP will broken. Okay, so this is the include any. You can say include any. This is the OR operation. Include all, that is AND operation. All will be available, then it will work. Otherwise not. So we can configure this one. How to configure this? Just set level switch path, then path name is VMX 1 to VMX 5, then admin groups, admin group, then you can specify the name. You can exclude groups, all of which must be absent. Include all groups, all of which must be present. Include any groups, one or more of which must be present. Okay, so I choose here include any. So this is the example. Okay, this is the example. Say here. So you have to reconfigure this one. No CSPF will be deleted. Level system. Now it's okay. For CSPF, we have to configure the admin groups, apply the admin groups in the enterprise. And third one is in LSP, you have to define the admin groups. You have to define the admin groups. This is the adapted most fail sort. Copy this one. So admin group include any, then the admin group's name. You can assign multiple. High bandwidth, enter. Then another admin groups is available here. Brand new. Brand new. Okay. So now it's okay. See here. The admin group include any, high bandwidth, and brand new. So in your path, if anyone is available, your LSP will work. So this is the logic. Okay. Third way to add admin groups constraint, that is exclude. You can exclude admin groups. This is the another options you can choose. So see here, the show compare, include any high bandwidth, exclude brand new. You can include someone, you can exclude someone. Okay, that's completely depends on a build. Okay, and this is the verification. Show MPLS LSP name R1 to R5 date. And this is the include any, and this is the admin groups, change admin groups options. So you can check, you can check MPLS and show MPLS LSP name is BMX1 to BMX5 and next say here, and this is the admin groups, brand new high bandwidth. Okay, so we're using only single router. My LSP is down because others interface no admin groups. We're only adding the admin groups in BMX1. That's why my LSP is down. Okay, so need to configure in all router. Otherwise, it will not work. Okay. Tagging a link once an LSP is already up. So what if you tag a link after an LSP has coming up? By default, nothing happens. Once an LSP is up, it stays up, does not look for changes. LSP prefers stability over all else. However, you can change this behavior. Okay, you can optimize the LSP in regular interface. So this will be covered in RSVP LSP optimization. Okay, real world use case maintenance windows like this, admin groups, maintenance admin groups, caveats. So if you deploy the admin groups, there is another configuration in your MPLS backbone router. Create the admin groups, assign the admin groups in interface, and also define the admin groups in your LSP. So there is the three step you have to complete in uh, in your MPLS backbone routers. Okay. So this is the ending of this section. So now we are in question and answer section. Number question one is what happens if you add a tag to a link when an has come up? The LSP stress up doesn't look for changes. The LSP can be configured to self-optimize at regular intervals. We're doing this in LSP optimization section. Which cover shows the admin groups that are associated with this interface. Show MPLS interface. Show MPLS interface. And this is the admin groups constants. Include any, include all, exclude. Include any, that is or operation. Anyone will be present. Your LSP will be communicate. The link is valid if it is tagged with at least one of these admin groups. Include all. The link is valid if it contains all of these admin groups. And exclude means exclude. The link is valid if it does not contain any least one of these admin groups. So that is end of this section. So thank you very much to stay with us. So today, our session has finished. Our next session will be the topic is RSVP, LSVP failures, errors, and session maintenance. Till then, Allah Hafiz.